Good morning, good afternoon, or good evening. Welcome to the first of WDO's member webinars for 2026. So glad to have you with us today. Really looking forward to having you join us for today's session. The next 60 minutes promises to be very, very interesting and engaging. So very pleased to have you join us. If today is your first time, please, we welcome you. We want to first and foremost ask you to perhaps don't be shy, use the features that we have on Zoom, use the chat features to maybe say hello, maybe share where you're from, as well as to use that function later on to ask any questions that you might have or comments about today's session. We're very pleased to be here today with one of our members from Malaysia, APU, for today's event, Designing Forward, Shaping Creative, Resilient, and Award-Winning Designers, a topic that is indeed near and dear to WDO's heart. These member webinars are, in fact, a great opportunity for us to stay engaged, to stay connected with our community, to present great content for our global network. So we're really pleased to welcome APU today to share a little bit more about how they have put together and established their Eco Innovation Lab. Joining us today is Miss Christine Lim, who has been actively involved in education for over a decade, bringing a unique blend of academic expertise and industry experience to her work. She currently manages two key programs at Asia Pacific University in industrial design and master's in design innovation management. Her career spans both the professional design industry and higher education, giving her a holistic perspective on bridging theory with practical application. Christine is passionate about fostering collaboration between academia and industry, aiming to create meaningful connections that drive innovation and real-world impact. Christine, we're so pleased to have you join us. We know that you are also here with a number of your colleagues, and we give you now the microphone to take us through today's webinar. Christine?
Hello. Thank you, Andrea, for the introduction. So let's get it started. So we are delighted to welcome everyone to today's webinar from Asia Pacific University of Technology and Innovation, APU. We are located in Kuala Lumpur, Malaysia. At APU, technology is at the heart of our education, but we believe true innovation happens when technology meets creativity, sustainability, and human-centered design. So our goal here is to nurture designers and innovators who create solutions that not only for functional, but also meaningful and responsible. So in today's webinar, we explore the connection between industrial design, culture, and sustainability, reflecting APU commitment to develop future-ready professions. We hope that these sessions will inspire new ideas, fresh perspective, and meaningful discussion. So in the first half of the session, the two key takeaways from today's webinar are how design empathies help identify real users' pain point. And the second point is how culture, nature, the tradition can inspire impactful and design solution. So in this session, we will be using James Dyson Award winning projects as our main examples. So just a little bit of what James Dyson Award is. It is an international design competition that celebrates and encourages the next generation of design engineers. It is open to current and recent students. So in APU, we are proud to achieve 5 James Dyson Award national wins, including 1 runner-up since 2020. And in 2025, which is last year, we are honored to be in the top 20 global finalists, selected from over 2,100 entries across 28 countries and regions. So let's get it started. So before we start, I'm just going to introduce you the mentor behind these award-winning projects, Mr. Eekang Oi. He's a respected industrial designer and educator in Malaysia with experience in designing and producing over 500 products for global markets. He is also among the few professions in Malaysia to hold the certified industrial designer status. With his extensive experience, he is well positioned to share these valuable insights on using culture, nature, and tradition as inspiration for our meaningful design solution. So over to you, Mr. Eekang, to answer the first $1 million question. Where does the idea came from?
Thank you so much for the kind introduction, and thank you all for being here. So this is the question, isn't it? The $1 million questions. And where is this idea come from? Well, I'm not here to reveal a magic formula or give you a perfect answer. I'm here to show you sometimes messy human journey that leads to our winning ideas. The journey to those ideas isn't linear. It's not neat. It's not a step-by-step process. In reality, it is something more organic. It's a dynamic flow driven by a genuine love for discovery. But for that flow to even begin, there is one non-negotiable prerequisite. It is not a tool or a software or a methodology. It is a foundation of trust and mutual respect between me as a mentor and the student as creators. Once that foundation is firmly in place, everything moves. Students become able to receive critical feedback not as a personal criticism, but as an essential guidance. This openness is the key. It allows them to generate crazy ideas, build ideas upon ideas, iterate without fear, and truly advance in their design. My role then becomes one of the strategic intervention. That is to save them time, to connect them to knowledge beyond their current scope, and ultimately elevate their creative experience. It is within this framework that the magic of ideation is finally set free. Let's dive into our first James Dyson Award win in 2020. The project name is Kuno, and Kuno is a sustainable cooler fridge with zero electrical power to run. The project is designed by student Kuan Wei King and Theodore. At that time, the Sustainable Development Goals, or SDG, were trending in Malaysia, and that's exactly where our idea began. We focus on goals aimed at empowering rural communities. Specifically, we asked how could food preservation make a difference? Our students observed a critical gap. Electricity was available, but refrigerators were not. Many indigenous households had no way to preserve their fresh produce. Now, why does solving this matters? It is not about appliances, it is about agency. Preserving meaning of less waste from daily harvest, more security over their food supply, and greater reliance, the ability to control their own consumption and their resources. In short, it is a tool for resilience. That insight became our starting point, our moment of empathy. Then came the second inspiration, something rooted in local culture and also deeply rooted in me. It's the Labu Sayung. It's the humble, traditional earthen water pitcher from Kuala Kangsar, which is a small state, a town in Perak. The pitcher uses natural evaporative cooling principle to cool down the water, a feature that has fascinated me since childhood. Now you might ask, why this ancient design and not so fancy material, which is clay? The answer is central to our mission. We knew we couldn't create something so expensive that the community couldn't afford it. That is the foundation where we started to explore. And during their exploration, the students innovated on the design by adding a middle layer, as you can see in the diagram. And this sand layer is the retainer, allowing the water to seep through it slowly. and become more effective compared to just putting water in there. So from this exploration of childhood's fascination refined by my students' ingenuity, we carry forward this core idea that inspiration is everywhere, and good design often lies in reimagining the fundamentals. Now let's move to the next design win, shall we? Water pot within in the year 2021. It was designed by a student of three students, Benny Low, Lu Xingyan, and Yap Chun Yin. Benny Bear. Water pot is a sustainable desalination pot that works on solar distillation to convert seawater into drinkable water. By utilizing natural resources, water pot is designed to be placed on the sea for the sea nomads to have access to drinking water easily, as illustrated. The idea to help the sea nomads community started when an NGO in Sabah, Borneo contacted me. This was during the lockdown, the MCO period. We are unable to fly over there to carry out our primary interview and observation. The ideation process relied mainly on online meetings and a lot of YouTube's hours. Later, the student discovered that the community doesn't have direct access to clean water. They must get it by trading or buying from nearby villages. That sense of empathy really motivated my students to try and solve their water access problem. And mind you, the NGO contacted me not because of water pot, but an entirely different matters. And guess where is this inspiration of water pot came from? My student noticed that close to the sea around the nomad's home is surrounded by mangrove forests. We were fascinated by how these trees can grow in salt water. Looking deeper, we were even amazed by the unique photosynthesis process, in which led us to the big idea: could we mimic the mangrove root to naturally draw fresh water from the sea? Now, with that simple question, my student starts to work. If you look closely at the ideation sketches, which I will show you in a few seconds, you can see the mangrove tree inspire the design. The leaves are transformed into the top layers where seawater is evaporated through a dome-shaped surface. The roots that reach down into the sea become the wick, drawing seawater upwards via a capillary system. The student works through numerous design and iteration, eventually to prove their concept. Let's move to our next project. Brick Coolie is our next project, developed in 2024 by the graduating students team, Wayne Chong Chikin and Nixon Ng Ka Chun. Brick Coolie is an innovative passive cooling system made from breathable bricks. Designed specifically for tropical climates, it effectively reduces indoor temperature without using any electricity. It is ideally suited for a variety setting, including landed property, apartments, and high-rise offices. Now, guess where is this idea come from? The idea for Brick Coolie begins with a real-life problem. The students' parents were frustrated by the high electricity bills from constant air conditioning. When the team brought this problem to me, I suggested them to look to the human body's own cooling system. How perspiration creates a cooling effect. When you sweat, you blow on it, you feel cool. And this insight leads my students to research further, drawing inspiration from ancient architectures, the natural design of termite mounds, all these connections, putting them together, and after iteration, they get the right design. Let me share with you how it works. Now, in the diagram, as you can see from the left, the warm outdoor air is drawn in through a strategically placed ventilation hole. This air passes through a complex 3D printed internal mesh, which is the core of the engine of the breathable bricks. The mesh is kept consistently moist by an integrated water system. As the air moves through the dam mesh, water evaporates, and this process naturally cools the air. The newly cooled air is then channeled into the building interior, and this effectively lowers the overall indoor temperature. The main cooling system operates completely without electricity, therefore cuts energy costs and reduces consumption. You can see the result of their testing here. The orange line shows the box without brick cooling installed, and the blue line shows a lower temperature with brick cooling installed. Finally, I would like to present to you the latest James Dyson win, Unblock. It was designed by a team of 3 students, Eun Won Kai, Natalie Tam Lee Ting, and Ong Jing Ro. Unblock make it to the global top 20 finalists last year, as mentioned by Christian earlier, representing Malaysia at the global stage. So what is Unblock? Unblock addresses a common household problem, that is to prevent the used cooking oil and grease from clogging kitchen sink and polluting waterway. Now, Unblock is not an industrial solution like the one that is being used by big franchise restaurants, but it is designed especially for under-sink installation in our home. And guess where is the idea come from? Similar to brick cooling, this project began with a real-life problem. Several team members experienced clogged drain at home, including myself. In the past 5 years, I think I unclogged once. That is due to the type of food that we eat here in our region. We have a lot of spicy food, deep fried food, and a lot of the time when you wash the dishes, all this oil residue will go down into the drainage, and the cool temperature will eventually harden them, and then they become problems later. Okay. Anyway, the students also at the time enrolled in the sustainable material class. And these connections allow them to apply the knowledge that they have learned to test various agricultural waste as potential material for oil absorption. As you can see in the next slides, eventually they choose to use the most abundant agricultural waste available, which is the palm oil industry waste. However, the student did not stop there. They reasoned with me. They say, if I want to go into the real world, if I want these products to be used by the real world, I cannot stop at the product stage. So I asked them, what do you want to do? They say they are looking into a complete ecosystem that will be able to close the loop. And that is the knowledge that they learned from the class about circular product design and circular economy. They do not want their solution to stop at the product stage. Therefore, they say that many good products fail to launch and sustain usage because there was no ecosystem to support it. I couldn't disagree with them, so I allowed them to continue to explore using their knowledge from circular product design and circular economy, and they created a system that eventually can monitor the product end of life. Now, this system eventually caught the attention of an industry player who is pioneering in biodiesel and aviation fuel made from used cooking oil. The industry is now talking to us, and we are looking to bring this project to the real world. So in conclusion, I think today we spend a lot of time, perhaps too much, relying on internet access. Every single time when I ask my students to start research, they will pick up the phone, they will look at the screen. I think there's nothing wrong with that. Okay, but we cannot forget the fundamental human skill of empathetic observation. And this is how we truly connect with the real world problem. And we are truly connecting, we are designing for human or maybe for animals. You have to go and talk to them, face them, see them, observe them. Then you should be able to identify their pain point. And from there, you can take it as part of the point to move on, for example, to bring another local heritage. And this unique culture, I think most of the time is overlooked by the high-tech seeking professional. But if you can see from our examples, a lot of our ideas came from very fundamental, basic, and authentic ideation. Okay, so by combining empathy, heritage, and fundamental principle, we can create design to me that is human-centered, grounded, and ready to make a real impact. That concludes my presentation. And now it is my great pleasure to introduce our next speaker. Please join me in welcoming Mr. Liew Yong Kian. Yong Kian is not only an educator, but also an accomplished industrial design and a practicing artist. I try to collect his art, but it's not easy. He seamlessly blends theory with real-world application. Furthermore, he is passionate and dedicated advocate for sustainable material and eco-friendly innovation. Please welcome Yong Kian. Yong Kian, over to you.
Thank you, Eekang. Today, I would like to briefly share a reflection on what we practice here in APU to develop stronger designers for the future. All right, in this session, the key takeaway will be how APU actually training award-winning designers through collaborations and commitment. The role of designer has shifted significantly. Designers are no longer working in isolations or producing purely visual outputs. They are now expected to engage with sustainability, technology, users, communities, and real-world constraints. Designers need balanced creativity and rigor. In this environment, individual talents alone is insufficient without collaborations and dedications. One of the modules in the industrial design program is industrial projects, where students are exposed to real-life projects and students are required to deal with real-site observations and data collections to identify the real-world problems. Industrial project brief will be discussed in the studio critics and industrial visit. Interdisciplinary teams of lecturers, industry experts are guiding the student in the projects. What is effective collaborations? We can see that effective collaborations does not happen just by default. Simply placing students into groups doesn't guarantee a meaningful teamwork. For collaborations to work, both students and lecturers take active initiatives. Students need to commit to their groups, take responsibility for their roles, and engage consistently throughout the project. At the same time, lecturers play a critical role in structuring collaborations by setting clear expectations, guiding groups formations, monitoring progress, and when initiative and commitment are shared, I believe collaboration becomes a powerful learning process. This process took different duration of time to complete, depends on industry requirements, rather than limited by the semester durations. In APU, students from various countries, cultural background gets together to organize events with lecturers. One of the examples is the annually World Industrial Design Day celebration in APU, where students learn the meaningful collaborations by taking their initiative to join as committee to host sharing sessions, workshops, design exploration games, and many more. This makes the students really understand the learning is not just merely depend the activities happen in the classrooms. What's the difference between collaborations and teamwork? In collaborations, we look into a very dynamic process where multiple stakeholders come together, co-create, negotiate, and shape outcomes together, often come from across disciplinaries. Emphasis on shared ownership and mutual learning. Decisions are negotiated horizontally in a group of members and experts with justification and evidence. This can be achieved with industry-based projects. However, when we talk about teamwork, this is mainly work well for studio project, where every student in the team just fulfill their assigned roles. Responsibilities are segmented. Feedback flows vertically, where depending on the lecturer giving feedbacks to students how to improve their projects. So besides we talk about collaborations, dedication is another part which is very important. Dedication in design starts with having clear process. When the process is clear, design students know what to do rather than jump straight into final solutions. This leads to a consistency in decision making, where choices are based on evidence, criteria, rather than personal preferences and convenience. If you look at the slide, here is one of the example. A student from Egyptian student named Mustafa. He actually take his own initiative and additional time to join in this industry project to design a lighting using sustainable material developed in the Eco Innovation Lab in the university. He took the initiative to organize meetings, gather feedbacks, collaborate with the engineer students, source for lighting components, build and prototype the lighting design. He also took the initiative to work with lecturers to open for market feedbacks for the design. And this allows the students to gain a deeper understanding of current market trends and to design solutions that are aligned with local market needs. This engagement helps students validate their design decisions, respond to a real user expectations, and develop commercially relevant outcomes. In other words, the design is actually accepted by the industry and can be commercialized. So the university respond quickly to the industry needs in sustainable by setting up the Eco Innovation Lab. Here in APU, we love to call it the material kitchen. This space allows students to experiment with developing new sustainable material, leading to material innovations and practical sustainable solutions. Students work with waste material industry, buy a product or discarded material and off-cut. And some of these projects has gone on to receive recognitions, including achievements such as the Dyson Awards, research project grants, and trademark registrations. Besides students take the initiative, I think we also have lecturers who are very committed to consistently connect students with the industry experts, to work closely on their projects to ensure all the design created is feasible and tested to be functional and manufacturable. Industry feedbacks is consistently gained from our partners to build stronger designer as well. Learning environment must intentionally embedded with effective industry feedbacks allow students to receive regular critiques and gain exposure to the real-world constraints such as time, material, user, project durations. Project duration beyond the standard semester time frame enable deeper iterations, reflections, and validation, mirroring the professional design practice rather than short-term academic exercise only. So collaboration and dedication from students and lecturers are essential to the successful development of strong designers. As a conclusion, strong designers are not born, they are developed. Collaboration builds perspective and empathy, while dedication builds credibility. Cultivating designers who can work effectively together and think systematically has proven to be crucial. This approach has successfully produced many award-winning designers at APU. Here are some examples of our students who are winning competition globally and locally in Malaysia. Here come to the end of my sharing. Thank you for your time and attention. I hope this short sharing encourage reflection on how, as an educational institution, we can develop stronger designers through collaboration and dedication in the era of complexity, where designers must navigate interconnected challenges. Thank you. So now I pass the stage back to Dorothy for Q&A sessions.
Thank you, Yong, Kian, and the team for this enlightening presentation. So hello, everyone, and thank you for joining today's webinar. My name is Dorothée Bollard, and I'm WDO's Community Engagement Officer, and I work closely with WDO's 200 plus member organizations, including APU, to deliver engagement activities like this one. So if you are new to WDO, or maybe you've been watching our work from afar, then I do encourage you to explore the benefits of WDO membership. I'll be adding some useful links into the chat during this webinar. So now we'll continue with the Q&A session, and we've already received some questions, so we'll jump straight in. So the first question, can you tell us more about the actual National Dyson Award Prize? Is it a cash prize for the students or for the school, for example?
Okay, I'll take this question. So basically, the prize is actually all given to the student, at least for our university. So there's we are just a mentor over there. So the national winner prize is about ringgit Malaysia, is about 27,800. And if you're a national runner-up, you just get recognized, but you get the eligibility to go up to the international stage, yeah, if your project is being selected. And for global prize, if anyone wins in the global top prize, for ringgit Malaysia is about 166,000, and I think so in pound would be 33,000, yeah. So that's the gist about the amount that if you win in James Dyson Award.
Fantastic. Thank you very much, Christine. How can designers collaborate across disciplines without diluting design integrity? I think maybe for you, Eekang.
Design ethical when it comes to designing products for the real world. It is not a very rigid thing. It's evolved along the way because the original idea from the industrial designer will, let's say, for example, go and work together with the electronics PCB makers. They will probably have to change a little bit to accommodate their requirements. Therefore, I don't see that this is going to be a problem. I think the most important thing is to understand the main objective of the project. At the end of the day, the project have to work. To work, meaning here, to be able to produce and sell. And to reach there, the designers, I know that the students always ask me, how am I going to keep my original design? I say, yes, the original design most of the time will be there. But it might not be 100%, it could be 90%, it could be 80%. So the designer has to give and take. The designer have to understand that they are designing for constraint like manufacturing, assembly, and even the finance constraint can come and say, let's shrink the whole thing. and you just have to change that. I think, yeah, that's my answer to the question.
Thank you. Thank you very much, Eekang. How long do each of your real world projects last?
Just to share my experience here in APU, we deal with a few industry projects. We talk about a real life project. I believe we have project, for example, from a bus stop design project, which is took around 2 to 3 months, up to a lighting project, what we showed just now, around 6 months. And we also go up to trophy design project for the industry. Took almost a year. And also we have grant project with industry, which is took up around 2 years. So that's why I mentioned just now in my slide, the duration is not really limited by the semester duration. It's about the requirement of the industry. And this work really well because this allows students to really experience the whole loops of how the design from ideation to the commercializing of the design at the end of the day. So we want students to really experience the full process rather than just an on-paper design proposal. Yeah, I think that is what we experience here in APU.
Fantastic. Thank you very much. We have a question in the chat. So how can empathetic design move beyond understanding users' needs to responsibility shaping their behaviors, values, and well-being?
Allow me to give a simple example in my class. So in one of my class, a student actually go and observe the animal shelter, the SPCA in Malaysia. So he go there and visited the place and start seeing the workers or the volunteers actually preparing the food for all the animals. And in the shelter, there are over 1,000 of dogs and cats. And you just imagine the amount of food. The students see they have to prepare 10 or more kilos of food just to feed all the animals every day. And the numbers of volunteers is, I think, less than 5 persons. And the students start to realize that seeing how they repeating the same movement all over and over again just to move the food from kitchen to the shelter to feed the animals. And he start to feel empathy because it's very tiring. So I think this gives a good exposure to the student in terms of empathy, and students start to change their behavior. They start to see how they need to look into their surrounding in a more critical manner. They also appreciate more, I believe. They are not just taking for granted in their life. And I believe when they're able to take care of things around them, I think that will for sure will improve their well-being, even personally as a human or as a person. That's what I see in my class.
Fantastic. Thank you, Yong Kian. Eekang, did you want to add to that question or?
I think it's adequate, right? I was going to touch on design for behavioral change, but I think I'm not going to go into that for now.
No problem, no problem. Okay, so how are AI tools being integrated into teaching at your school, particularly in relation to coursework and product development?
So thank you, Mr. Oliver Lin. Yeah. Definitely we are a technology school, so AI is something that we pretty use quite often, and we will need to adapt, and we can't stop students in using it. So definitely we integrate using AI to generate ideas, as well as I would say generating design. Yeah, students will still need to come up with sketches, basic sketches, their ideas. We still enforce that they still need to do brainstorming through paper and pen or digitally, but using AI to quickly visualize on material use, how things are being composed together. So I think this speed up the way we visualize design. Yeah. So we don't need to wait for them to build a 3D anymore. So these things actually help students to see things clearly, especially at the lower semester student. Yeah. However, for design execution wise, that's where the mentors or the lecturers are really important to make sure that the design that is being selected, the design that is being developed is then be realized, be able to be realized as close as in reality. So if you talk about documentation wise, when they submit, can they submit a fully AI work? So at the end, it depends on the module, the nature of the module. So generally, all design needs to be executed, and any AI work needs to be addressed in documentation. So that's how we work in APU at least, or in our design school. Hope that answers your question.
Fantastic. Thank you, Christine. We've had a very big question, so I'm not sure who wants to answer this one, but does AI pose a significant threat to the field of industrial design? And is it possible for AI to eventually replace human industrial designers?
I think I can talk about that a bit through my experience with my student over here in APU. We can't deny AI is here, I believe, especially in the design industry. And I believe in the industry, AI is encouraged and even speed up all the design process. Here in APU, we do encourage students to use AI in certain tasks, I believe. And here, I think empathy is very important, like what we shared during the sharing just now. Because when students with empathy, they start understand what is important, which area aspect that they can take a shortcut, and what area they should not take a shortcut with AI. So empathy helps a lot, and when empathy coming in, they start to understand what is research ethic, what is design ethic. I believe all this will help a lot in terms of allow students learn how to use AI ethically. I think this is also one of the aspects we stress a lot over here in APU. I think in the meetings, I think lecturers talk about it, how to guide students in AI usage for design, and also what level of usage is supposed to be allowed, and so on. So I think this is something we are encouraging students to explore, at the same time explore with a lot of ethical, I think.
Thank you. Does anybody else want to add to that question? No? Okay, we'll move on. So, do you encourage your students to intern internationally? So we have someone who's interested in perhaps taking one of your students as an intern.
Yes, we do welcome our students to do intern. I think in APU, we have over 110 countries of international students. So we allow them to intern back in their hometown or any countries, as long as they have no visa issues. Other than that, they can, and our internship is about 4 months. So we welcome anyone who wish to take in our interns.
Great, thank you, Christine. And then the final question. So how many award-winning designs have transitioned from prototype to mass production and or marketable products?
I think I've answered that, Basically, we are still looking for interested parties to collaborate. So please feel free to connect with us to further commercialize all the designs. And may only unblock now, we are working with one of the industry players who are interested to further develop. Other than that, we are still hoping to wait for these brilliant ideas to be commercialized to connect me.
So thank you, Christine. And so I think just one final question has come through. I want to, in regard to empathetic design approach to software for prototyping, before recreating that same piece physically, what software do you use for producing such results?
Yeah, I think I will just pick up this one because I'm reading the question. Okay, I think over here I can talk on behalf of APU, not generally for industrial designer around the world, right? In APU, we are actually using quite a few numbers of software for industrial design, from the basic SolidWorks to Keyshots to Rhinoceros, and we also encourage students to use some open access software, free software that available online if they feel comfortable with for a quick prototyping. Let's say they build some basic 3D models and then send for 3D print just to study how the thing will look like in scale model before they build the real physical model. So we also encourage students actually exploring the manual method, manual way of doing it by really walk into the workshop and then pick up a piece of wood or foam or clay and then start shaping it. I believe that will allow students to really see the design in a more three-dimensional visual, and that's helped in how developing the design. Yeah, I think hopefully I'm answering the questions.
Thank you, Young Kian. So with that, this concludes the Q&A session. So back over to you, Christine. Thank you, everyone.
So I would like to thank WDO for giving us a chance to share our work, and special thanks to Andrea and Dorothy, and finally to our audience for staying with us. Yeah. So looking ahead in 2026, we are welcome to anyone who is interested to collaborate and commercialization or on sustainable solution. Any academic or interdisciplinary partnership, we welcome them as well. Just feel free to connect me. And you can also follow us on Facebook, yeah, APU, yeah, as well as our design school page. So Matt, yeah, we are the Matt people here. So yeah, so I think that's it for today. So really, really thank you, WDO, for this opportunity, and thank you for my colleagues in this sharing. I hope everyone enjoy, and I put my link there as well. So thank you.